Assalamualaikum. Hi everyone, welcome to my video. My name is NABILAH HUSNA3 and today we will discuss on how the physics of football works or the physics of building a better football. Before we start, I'm going to show you a video of our Malaysian footballer Safi Sali.
Tak berjalan lepas. Dapat dikawal oleh situ Syafiq. Terus kepada Kunalan. Kunalan dan Syafiq. Dan akhirnya memberikan kepada Mahal Jusali. Hantar ke depan Masali. Asa cantik. Lakukan oleh Safi Sali. Tandukan open yang terbuka. Tandukan dilakukan oleh Safi Sali. Safi Sali.
How the physics of football works? The first one is delivery of a football through the air. When the football travels through, it always follows a curve or parabolic because the movement of the ball in the vertical direction is influenced by the force of gravity. As the ball travels up, gravity slows it down until it stops briefly at its peak height. The ball then comes down and gravity accelerates it until it hits the ground. This is the path of any object that is launched and is called projectile motion. The angle of a kick helps determine how far it will travel. The way to get the maximum range from a projectile is to launch it at a 45-degree angle in condition air resistance is negligible. You can refer the picture below. We move to the next point, the Magnus effect. Have you ever heard that phenomena? Before we proceed, I am going to show you again a video about the impossible free kick by a young Brazilian player named Roberto Carlos.
Well, the way to look at the ball, look at the way he's got it there. He's got it in his hands, he's having a good careful look about it. It's placed absolutely perfect. I mean, everything's set that he's going to hit it. I just wonder if they're kidding us on.
This one, all of 30 yards, Andy.
Why not? It's a 30-yard free kick with a 20-yard run-up.
Dear, I don't believe it. What a goal we have just seen from Roberto Carlos. That is amazing.
Well, that was what was missing in Euro 96. That is quite incredible. Not so sure about the goalkeeper's position and what he saw, but we can't deny the quality of the strike. It had power, it had bend, it had accuracy. Watch this. Starts way wide of the goal. That's 2-3 yards wide and just clips the inside of the post. That is quite a magnificent free kick. I'm not so sure we'll see one better than that for many a year. Quite exquisite.
In 1997, in a game between France and Brazil, Roberto Carlos set up for a 35-meter free kick. With no direct line to the goal, Carlos decided to attempt the seemingly impossible. His kick sent the ball flying wide of the players, but just before going out of bounds, it hooked to the left and saw into the goal. According to Newton's first law of motion, an object will move in the same direction and velocity until a force is applied on it. When Carlos kicked the ball, he gave it direction and velocity, but what force made the ball swerve and score one of the most magnificent goals in the history of the sport? The trick is in the spin. Carlos placed his kick at the lower right corner of the ball, sending it high and to the right, but also rotating around its axis. The ball started its flight in an apparently direct road with air flowing on both sides and slowing it down. On one side, the air moved in the opposite direction to the ball's spin, causing increased pressure, while on the other side, the air moved in the same direction as the spin, creating an area of lower pressure. That difference made the ball curve towards the lower pressure zone. This phenomena is called the Magnus effect. Last but not least, I have one question for all of you. Why do players kick the ball high in order to score a goal from a long distance? Thank you for watching my video. See you soon.